Good afternoon, teacher. Good afternoon, classmates. My name is Freddy Camilo Antonio Murcia. I'm going to present the derivation implications in a nuclear energy and subatomic particles. The equation E equal mc squared. Introduction. I'm going to explain the equation. How is the equation E equal mc squared mathematically derived from the postulates of special relativity and what implication does it have in the field of the nuclear energy and subatomic particles? Einstein's theory of special relativity, published in 1905, revolutionized physics by introducing a new framework for understanding space and time. It is based on two key postulates. The first, the principle of relativity, and second, the constancy of the speed of light. The postulates. The first postulate explains that the laws of the physics are the same in the all inertial frames of reference. This means no experiment can distinguish between being at rest or moving at a constant velocity. The second postulate, a constancy of the speed of the light, is constant and doesn't depend on the motion of the source or the observer. Relativistic energy and momentum. The equation E equal mc squared have the energy with the letter E represents the total energy of the system, including both its rest energy and kinetic energy. The momentum with the letter V describes the motion of the object and given by the Lorentz factor, and the letter M, mass, represents the rest mass of the object, a measure of the inertial and energy content when at rest. Implication in nuclear energy. There are two implications. The first, fission, splitting by heavy nuclei, for example uranium, releases energy due to the mass defect, where a small amount of the mass is covered into a large amount of energy. This powers nuclear reactor and atomic bombs. The second implication is fusion, combining light nuclei, for example hydrogen, releases energy as the resolution nucleus has slightly less mass than the original particles. This process power stars and is being harnessed in experimental fusion reactor. Implications in a subatomic particles. The first, particle-antiparticle annihilation. When a particle emits its antiparticle, electron and positron, for example, their mass is converted entirely into energy, typically as photons, for the equation E equal mc squared. The second, particular creation. High energy collisions, for example in particular accelerator, can convert energy into mass, creating new antiparticle pairs. This demonstrates the interchangeability of the energy and the mass. The second equation is what is the relationship between relativistic energy and the conservation of energy and momentum in high-speed particle system. The context in conservation of the energy takes a deeper meaning by unifying energy and mass through Einstein's famous equation. In especially relativity is the total energy of the system, which includes both rest mass energy and kinetic energy, is conserved in isolated systems. In relativity, the conservation of momentum is closely tied to the conservation of the energy and is a fundamental principle of the both special and relativity and general relativity. The total momentum is a isolated system remains constant, used as a classical physical, but now incorporate the effects of time dilation and late contraction. Conservation of the energy and momentum is a relative system. In high-speed systems, both energy and momentum must be conserved relativistically. The total energy and momentum before an event, for example, a collision, equal total energy and momentum after the event. Elastic and inelastic collision and at high speeds. There are two kinds of the collisions. The first, elastic collision, kinetic energy is conserved, particles retain their identities. And the second, inelastic collision, kinetic energy is not conserved, new particles may form. For example, creation of particle-antiparticle pairs in high energy collisions. Implication of the astrophysics and cosmology. The high energy processes in stars, supernovae, and black holes, role of relativist energy in cosmic ray interactions, for example, relativistic jets for active galactic nuclei. And in conclusion, the equation E equal mc squared is a construction of the physics demonstrated the profound relationship between mass and energy. It shows the mass can be converted into energy and vice versa, and principle that underpins nuclear reactions such as fission and fusion. The second conclusion, in high-speed particle system, the conservation of the relativity, energy, and momentum is essential for the understanding interaction at velocities the speed of the light. These principles allows us to predict the outcomes of collision and particle accelerator, the creation of the new particles, and the behavior of coming rays. This was my presentation. I hope your feedback, and thank you so much, teacher.